Hey guys, I thought I'd make a little video because this has been a little bit confusing and I thought you might be able to use this when you're doing your homework. So this is the solving simultaneous linear equations using the elimination method, and here we have two linear equations. So you know, don't you, that if we were to draw this one and draw this one, there'd be two lines on a graph and at some point they would intersect. So what we are trying to do is find that point of intersection. All right, so let's go through what we would need to do to solve this one. I'll be writing the steps in my book so you can follow along. All right, so step one is to label. All right, so maybe in a different color. You're going to label your equations, equation 1 and equation 2. This is really important. Please don't skip that step, all right? And then we need to look at what coefficient are we going to try and eliminate or get rid of. And the key to that is looking for the coefficient or the number that is next to a pronumeral. The ones that are the same are the ones we're going to eliminate, okay? So in this particular set of equations, we're going to try and eliminate the 3, okay? So step 2 is find your coefficient. Okay, once you've identified which coefficient you're going to eliminate, the next step is going to be to look at the signs that are beside here and see what we need to do to these two sets of values, how we're going to eliminate them. Now, if we add 3y and then minus 3y, okay, we need to determine whether that's going to be a plus over here. We're going to add those two values together, or are we going to minus them in order to get rid of them? So it's 3, positive 3, because this is attached to this number, positive 3 plus or minus negative 3, all right? In this case, it's plus, all right? If you get stuck at this point, what you can actually do is use your calculator, and you can ask your calculator, it's positive, so positive 3, we don't have to put in the positive symbol, plus negative 3, so positive 3 plus negative 3 equals 0. So it's plus, okay? So that's why I've written that plus sign over here. If this was a positive number, positive 3 and positive 3, you would easily be able to identify that you need to take away that this should be a minus over this side. But this way around, it's a little bit confusing. So that third step can be a little tricky. The third step is identify whether it's a plus or a minus, okay? And that's what we've done there. We've determined that positive 3 plus negative 3 is 0. Now you can write 0 here if you wanted to, 0y or 0, but you actually don't need to do that. So now we're just going to treat this like any kind of sum that we would have got in grade 1, and we're going to say, what's 2 plus 5? 7, but we don't leave the x out of it, do we? Because it's 2x's plus 5x's equals 7x's. We're not going to worry about this because we've eliminated it, which means we've gotten rid of it. It doesn't exist anymore. 9 plus 12 is 21. So now we have 7x equals 21. I'm going to rewrite that so it's a little bit closer together and makes a little bit more sense. Now, the next step is to isolate x. Another way of saying that is to solve for x or find the value of x. So we need to get x by itself on this side of the equation, and we do that by getting everything that's not an x over here. All right, so we're going to recognize that there is a times in there, it's 7 times x, and we're going to do the inverse operation, which is divide by 7. Whatever we do to the left-hand side of the set of scales, we need to do to the right-hand side of the set of scales, okay? And that's how we write divided by 7 in algebra. We can then cancel that out. And what I mean by cancelling out is 7 divided by 7 is 1 and 7 divided by 7 is 1. So 1x over 1 actually just equals x. We're going to do the same on this side. How many 7s in 7? 1. How many 7s in 21? 3. 3 over 1 is the same as 3. So now we've solved and we have a value of x. You might like to highlight that, put a box around it, okay, because that's some important information. The next step is going to be to insert that value of x into equation 1. Insert x into equation 1. Now, it could actually be y that we've solved for, but in this instance, it's x. So it could be y, but not today. Today, we've actually managed to solve for x. All right, and we're going to insert x into 1. Here's 1 here. So I'm going to rewrite that out. Okay, we've got 2x plus 3y equals 9. And we have the value of x, so we're going to put that value in here, recognizing that there's a multiply in there. So let's keep those little friends together because it's important that 2 and x stay together, and we do that by putting brackets around it. And then you just write the rest of the equation out. Now we're going to try and solve for y here. You'll notice that we have only a y now, so we'll be able to rearrange this equation to solve for y. All right, so 2 times 3 is 6, plus 3y equals 9. Now, as you know, the object of the game is to isolate y, so this is kind of another step inside step 5. We'll call it step 6. We're going to isolate y. All right, so here we go back to isolating y. So the object of the game is to get y by itself, and we do that by getting rid of the things that are the furthest away from y, which is 6. So how do we get rid of a positive 6? Well, we take away 6, don't we? If we take away 6 from the left-hand side of the equation, it's gone. It's just disappeared, and all that is left is positive 3y. But whatever we do to the left-hand side of the equation, we must do to the right. So 9 minus 6 over this side. And we can just do some maths. 9 minus 6 is 3. And at this point in the exam, guys, you should be looking at these two numbers going, oh, yes, I've got it right because this is nice and easy now. Right? To get rid of the 3 on this side of the equation, it's a times in there. The inverse operation of times 3 is divided by 3. Whatever we do to one side, we do to the other. We can now simplify this. 3 divided by 3 is 1. Y equals 1. And just like we did before up here where we highlighted the fact that we now knew x, we can highlight the fact that we now have solved for y. The next step is to insert x and y into linear equation 2. So just up here where we've numbered the equation, going to rewrite that one out. All right, so in this instance it's 5x minus 3y equals 12. Now we have values for x and we have values for y, so we're going to insert them into here. Now remember that 5 and x are good friends. They don't want to be separated, so we're going to put those brackets around there. And 3 times y, well, y is 1. Put brackets around those guys. And now we've got no letters left in our equation, so we know we can solve this. So 5 times 3 is 15, minus 3 times 1 is 3, equals 12. 15 minus 3 indeed is 12. Does 12 equal 12? Well, yes, it does. Therefore, we can say that the values of x and y for these two linear equations, if we were to plot the graph and write down where those equations, those lines intersected, the coordinates of that would be x equals 3 and y equals 1. Okay, you can put an equal sign in there if you like. So I hope that's helped you, and I'll just get you the full shot now so you can maybe pause the video and have a look. But this should help you answer question 2. I think you're doing D, E and F. Good luck.